my my desktop. So we'll maintain 1 minute silence and then we'll resume back for the session. Om Shanti. Thanks for bearing in this condolence, and we offer our best, you know, wishes for the departed soul. And now let us begin our session with the lecture. Before that, I would like to introduce our speaker for today. We have with us Mr. Jaywant Chandane. Uh, he has 14 years of a practical experience. Jaywant completed his graduation in 2011 from MGM College of Engineering, and later on he joined Stoop Consultants, and where he worked for almost period of 8 years and in various challenging projects. And he did a couple of road projects and couple of railway projects like this Khurja Bhavpur DFCC project he was involved in. After 8 years of practice with Stoops, then he joined L&T for where he worked about the period of 2.5 to 3 years, and he was instrumental in so many good projects like Mumbai Vadodara Expressway, which was one of the difficult projects, and Aurangabad Korodi project, and some more bids which were there. After that, after completion of these projects, Jevon joined back to Stoop, which was that time Assistant Stoop, and he was posted on the very renowned project, that is Mumbai Trans Harbour Link MTHL project, and he was instrumental in design, review, proof checking, and various site activities. So you can see from his today's presentation. After that, he worked for a short time with Tata Consulting Engineers, and now he has joined recently Nikon Koi International. And I hope that you will enjoy his presentation. So I request Jevan to start sharing his screen and start his presentation. All participants, please keep yourself on mute mode. Thank you. Jevan, start.
Good morning, all. Today I am presenting design and construction aspect of the pretension U through girder in elevated metro. So, containing introduction, solve example is there. Methodology adapted. What methodology I have done in this to solve the examples.
Jevan,
Analysis how
just a
I
moment. Just a moment, one interruption. All participants are requested to ask questions in chat box. So either WhatsApp chat box or here itself, because this chat box is now open for question answers. So we'll take all the questions at the end of the session. So yeah, you may start.
uh, then analysis how the analysis has been done. Then the result and discussion and design and question answer. So this is the view of the metro, uh, like girder is there and all the metros infrastructure how it is. Uh,
Jayant, why don't you screen project it? Because in the left in the right lower corner there is a facility of
yeah,
presenting.
present.
Yeah, please present it so that animation also can be seen. Right side, right side. No, no, not that, not that. Right, right lower. Yeah, yeah, yes. Please present.
Uh, Now it is okay, sir.
What happened?
Is my screen is visible, na, sir?
Visible, but you are not presented. You are not presenting your screen. It's not on a presentation mode. PPT, it's normal PPT.
In my system, it is presentable.
Okay, okay, no problem. You can start the second slide. I think you have skipped, so you can start with the second slide.
Yes. Uh, uh, that is the introduction of U-girder. U-girder is come from how it is originated. It is originated by the single cell box girder, uh, and the leg slab has been removed. So the geometry has been converted into U-trap, and the formation level has been down to the base slab of the single cell U girder. So in figure we can identify that there is a abutment, and the with deck slab the level is higher level, and uh, at bottom slab the depth of the girder will be less. So by the approach of providing U girder, we can reduce the depth of abutment and approaches, and that is a phenomenon of the U girder. So we will move for next slide.
Jayant,
Uh,
your slides are not, your animation is not seen. Slides are not moving. Only one slide we are able to see. I think you have to share complete screen.
okay, okay. Uh,
Share entire desktop.
okay, okay.
No, no, stop sharing. I'll tell you, stop sharing. Yes. Now you can. Yeah, yeah, yeah. Present, present. Yeah.
Hmm. Uh, okay.
No, still it
So
is not. Yes.
the precast segmental channel U channel shaped is bridge developed by Jean Muller in 1990s for the complicated overpass in France. Actually, he is the bridge engineer. He's closely worked with President also, who has introduced the PSC phenomenon. So then the scroll causeway viaduct in 2001 to 2010 was built in Austria. It became the first channel of the bridge viaduct in the world. So then after the very famous consultant Sistra has been developed the precast Christes concrete U-shaped bridge based on original canal bridge constructed in France. So Sista has done very much research in U-girder, uh, and provided that patented also. So here are the different type of superstructures, in figure one we can see the twin U girder viaduct, then box type girder supporting two trap, I girder, then U girder with two track, and U girder with supporting single track rail. So our point of discussion today is U girder with supporting single track. Okay. Let me introduce the phenomenon of the post tensioning and pre tensioning. So in pre tensioning, the we have to first prepare the bed, and the cable are stressed. Then after the some 3 to 4 days, the concrete will be laying over the it, and at the time of transfer, there is some hogging portion we have to see in here. So it is because of the eccentricity developed in during the stressing transfer. So girder will be hog at the time of transfer, and then after it will reduce after application of sulfate and application of SIDL and application of live load. So we have to check hogging also in this girder. So this is phenomenon of the pre-tensioning. Then post-tensioning. In post-tensioning means the concrete will be pour first, and the tendon HDFC duct will be pressed along the profile. In that we have to freedom that we can profile the cable uh, inversely to the shape of bending moment, because in post tensioning we are give the tension to cable after concreting. So here we can do the profiling of the cable with respect to the shape of bending moment, and the number of cable will be there. uh, the HDAP pipe will be kept at the time of concreting. Then after achieving some strength, the tendon are placed at its position, and then it will be stressed. So this phenomena is for the post tensioning. Now we come to the losses in pre and post tensioning. So pre tensioning, the loss due to elastic deformation, loss due to relaxation of steel, loss due to shrinkage, and loss due to creep. While post tensioning, the loss due to elastic deformation in concrete if wire are tensioned successively. Suppose in beam there are three cables. So first we have traced some bottommost cable. Then there is no loss in elastic deformation in post tensioning. But after second cable will be traced, there is some loss in cable one because the shortening of the concrete. And third cable when we trace, then the losses, there is no loss in third cable, but there is loss in first and second cable. So successive loss is there in elastic deformation in post tensioning. Then loss due to friction. While stressing, there is a friction between concrete and tendon. So the loss due to friction is there in post tensioning. Loss due to anchorage slip. When the wedge are released after immediate stressing, there is a slip in the anchorage, so that will be maximum we consider 6 m. Then loss due to relaxation. The relaxation loss is the stress steel is relaxation over the period of time. So relaxation loss come into picture. Then loss due to shrinkage uh, uh, and loss due to creep. The loss due to relaxation, loss due to shrinkage, and loss due to creep are the long-term losses in uh, pre-stress. So the section analysis, when analysis the cross section, its ultimate strength of following assumption has been made. The strain distribution in concrete in compression is derived from the assumption that plane section remains plane. Okay. Then the stress in concrete in compression are derived either from the stress strain curve or the partial safety factor gamma m is 1.5 for FCK, or the case of in case of rectangle and plane section with the natural axis of in flange. For the compressive stress, it may taken equal to zero point 0.4 FCK over the whole compression zone. Here we are considering the zero point 0.4 FCK is uniform distribution in the compression zone. and in both strain outermost compression fiber is taken 0.035, the strain value of the concrete, and then the tensile strength in the concrete is been totally ignored. The strain in bonded pre-stressing tendon and any additional reinforcement where in tension and compression are derived the assumption that plane section remain plane. In additional tendon will initial stress strain due to pre-stress after all losses. It means the additional tension reinforcement also need to be considered. The stress in bonded pre-stressing tendon where initial tension or untension and additional reinforcement are derived from the appropriate stress strain curve with gamma is equal to 1.15 is factor of steel representing tendon. Here the diagrammatic represented of that concept of the ULS. Here it is x is the depth of neutral axis, and as a written in theory that point for FCK is a uniform distribution for stress, where mu is equal to FPB APS in the bracket d minus 0.5 x. So mu is the ultimate moment of resistance of the section. FPB is the tensile stress in the
हॅलो.
tendon at failure.
नमस्कार, बोला सर.
XU is the depth of neutral axis. D is the effective depth of the
बरं, मी
tension
तुम्हाला व्हॉट्सअप
reinforcement.
पाठवतो लगेच दुसरी.
And APS is the area of
हां,
pre-stressing tendon
व्हॉट्सअपलाच लिंक
in
पाठवतो लगेच.
the tension zone. So it is
हो हो
mentioned in
हो.
the clause number
स्टुडंट वेबिनार, हो, वेबिनारमध्ये
16.4.3
आहे.
of the IRS CBC.
हो.
Shear resistance of the beam. The theory also mentioned in IRS clause number 16.4.4 IRS CBC. Calculation of shear reinforcement and shear is calculated only for ultimate limit state. At any section, the ultimate shear resistance of the concrete VC
हॅलो. हां.
shall be considered in the both
हां, मी
uncracked
काल
and cracked
सरांना सांगितले, काल सगळ्यांना
in
फोन केले.
flexure, and any
तुम्ही
necessary
चेंबरच
shear
करू का?
reinforcement shall be provided.
बरं बरं
For a
बरं.
cracked section, the condition of maximum shear with coexisting bending moment and maximum bending moment with coexisting shear both need to be checked. The in calculation VCO, the value of FP shall be derived from the pre-stressing force after all losses have occurred, multiplied by factor appropriate value of the gamma FL is the partial safety factor of that. And then the FT mentioned is here. FT is the uh, tensile strain of the concrete is zero point 0.4 square root of FCK. FCP is the compressive stress at the central axis due to pre-stress. P is the width of the member, and H is the overall depth of the member. So by all this values will be give the VC, and the minimum reinforcement shall be provided by this formula ASV by SV is equal to 0.4B by 0.87 FUY. Here FUY is the characteristic strength of the stirrups shall be not greater than 415. Here suppose we use FV 500, then also we have to consider 415 only the maximum limit. ASV is the area of cross sectional of the leg. SV is the spacing of the stirrups, and minimum shear reinforcement shall not be less than 0.2% of the web area in plan for the mild steel and 0.12 of the web area in plan for HYSD bar. This is as per clause number 16.4.4 in IRS CBC. So before we can start the problem now. There are various software are used for the analysis. So I will present some few software here. The Stad Pro, Vidas, Sophistic, and Lusas. This is a graphic user interface of the software. First one is a Stad. Second is Midas software, and third one is the Sophistic, and fourth one is the Lusos. Both software has have their own advantage and disadvantages, and how the user is user friendly with the software that will be there. Now we will move to solve example of the U girder. So we have the problem statement of that the design of 31 meter span pretension U girder for the metro loading. So the length between pier center is 31 meters, and between bearing center is 29.6. Here I have considered zero point 0.7 meter distance from the center line of pier for the bearing. So zero point 0.7 plus zero point 0.7 1.4, and 31 minus 1.4 is 29.6. Then the top width of the girder I have considered 5.45. Bottom width of the girder I have considered 4.2. Overall depth of the girder 1.87, and concrete grade of concrete mixed design is M60, and Young modulus is 36 into 10 raised to 6. Density of concrete 25 kilonewton. Grade of steel is Fe 500. Precision ultimate tensile strength of stand in stand is 1860, and elasticity modulus of elasticity of PSC stand is 1.95 10 raised to 3. 1.95 into 10 raised to 5. So, and the nominal cross section area of the strand is 140 mm square. For the 52.7 15.2 mm 7 play system. Density of pre-stressed concrete is 25 kilonewton per meter cube. Here is the cross section as I mentioned in the dimensions over here. Here is the cross section of the U girder. So top width, total height, and wave thickness, uh, top flange, bottom and bottom width are exactly showing that the problem statement. Then here is the longitudinal view, which will show that the total peer to peer distance is uh, 31 meter, and bearing is zero point 0.7 meter, and zero point 0.7 meter is there. So we will our support center is zero point 0.7 meter apart from the center line of pier. So effective span is uh, we have to take 31 minus zero point 0.7 minus zero point 0.7, so 29.6. So we will design always the with respect to effective span, because our support is at uh, uh, effective span. So methodology adapted. The StatPro software used for main software for workout the analysis, and Excel used for presentation the result and conclusion. So the 2D analysis will be carried out for the longitudinal analysis, and 3D analysis will be done in transfers with respect to that plate element in StatPro. So U-girder act as a piston section in longitudinal direction, and it acts as a reinforcement section in transverse direction. The following code will be referred in analysis of the design of the U-girder is IRS bridge rules and design basis report for loading, and schedule of dimensions of metro issued by Delhi Metro DMRC, as the most project of India has been controlled and managed by DMRC only. And IRS CBC is a design code from the railway, uh, and IRS manual for seismic design. So basically, IRS bridge rules give all the loading details and impact factor for the loading live load. Uh, and the schedule of dimension will be considered from DMRC, and IRS concrete bridge is the design code. After analysis, we will design with respect to the IRS CBC code, And for seismic load calculation, we use seismic IRS seismic manual. The temporary stress in the extreme fiber, the permissible compressive stress in as per table number 24 of IRS CPC is 20 is actually zero point 0.5 of that zero point 0.5 of that at the time of transfer stress at the time of transfer. So it is I have considered 40 MPa. So 40 into zero point 0.5 is 20 MPa, and permissible tensile stress at uh, uh, temporary temporary tensile stress permissible is 1 Newton per mm square. But in uh, stress in extreme fiber at service condition, it is zero point 0.4 of the FCK. So as earlier mentioned, that if we have used M60 grade, so M60 into zero point 0.4 is 24, and there is no any tensile stress permitted during the services. So the girder dimension and the sectional properties calculated from AutoCAD. So 1.87 is the height of the girder, and cross section area of the girder is 2.183. Moment of inertia is 0.8835, and CG of from bottom is 6.657 mm, and CG from the top is 1.213 mm. This dimension we will refer further for the stress calculation at various interval. So this dimensioning is very important for the further calculation that properties mass properties of the section. Now the superimposed dead load is considered from DBR, rails, cable through cable tray, handrail, plinth slab, lightweight deck drainage, OHE mast, and miscellaneous. So for double track, its summation is 6.05. It is ton per meter, and for single slang is divided by 2. So 3.05 ton per meter. So intensity of dead load. Intensity now is we come to the loading part of that longitudinal analysis. So intensity of the dead load is coming from the cross section area into the density of concrete. So 1.87 into 25, it is 54.575, and superimposed dead load is 3.05 ton per meter. So it will convert into kilonewton per meter. 29.92 is simply multiplied by 9.81. And so we have also considered the solar panel load at the U girder. So it is zero point 0.5 kilonewton per meter. And live load intensity in DBR, they have given the it is equivalent uniform distributed load required for longitudinal analysis. So in DBR, they have provided a certain value of the EVDL for different length. So here for 29
Oh,
meter, uh, EUDL is for two types: maximum shear and maximum bending moment. So maximum shear for 20-meter span, maximum shear is
हाँ
131.85, uh, and for maximum bending moment is
हो हो तुमचा मी ॲप्लिकेशन मी
151.56,
फॉरवर्ड केले सरांना
and for
ते सरांनी
30
मला रिप्लाय
meter
दिला
span
कधी
is
मग मी लगेच रिप्लाय करतो सर
135.39 is for share,
यामध्ये
and for
ॲप्लिकेशन मी
bending
बनवायला
moment is
गेले सरांनी मला ओके दिलं म्हणजे
118.51.
कन्फर्मेशन दिलं
So
होतं चेक करून
we
तर तुम्ही मला
our
ते
span is
पाठवा
29.6. So by interpolating values, we will consider for 29.6 span, and it will be later work out for the per meter. Then the coefficient of dynamic argument is nothing but the impact factor uh, considered in our road bridges. So it is like that only. So our design speed I have considered is 19 kmph, and the code has given the CDA for 125 kmph. So CDA is equal to 0.15 plus 8 divided by 6 plus L. L is the span. So for 90 kmph, that ratio we have to multiply it. Then the modeling I have done instead. So superstructure analyze complete beam modeling represent the total length of 31 meters, and I have provide the node at certain interval. So it is required to provide and required to check the stresses at certain level around zero point 0.5 to 1 meter level. Every zero point 0.5 to 1 meter level stresses need to be checked. So for taking the bending moment and shear force at that location, I have introduced the node in between the throughout the span, and it is dimension is ranging between zero point 0.5 to 1 meter. The vertical train load can be uh, also carried out by running the length, running the train through the line model or the line model by providing a definition instead, live load definition. So this is also second method, but I have used equivalent EUDL method. So directly we will get we simply applied the UDL on the uh, our member. So property is mentioned is area 2.183 AX and here moment of inertia, the property of the member, and the loading part and start uh, self-weight of the U girder, SIDL, UDL for bending moment and shear force without CDA. So here the SIDL as calculated above is 54.575. Then the equivalent SIDL is 29.92 as calculated above, and solar panel load is single wave, so into 2, and EUDL is for bending moment and for shear force. It is per meter. Here we use have seen the values for the total length. So I have converted it to per meter length. Okay. Then the another loading is seismic load. Here we complete up to the live load. Then a seismic load we have to work out. Uh, I have considered the location is Bangalore, so there is zone 2. The coefficient seismic coefficient AH is calculated as per the formula below. AH is equal to Z by 2, I by R and SA by G. So zone 2, hence the Z is equal to zero point 0.1. Uh, that value I have taken from the IRS seismic code. As macro is important structure, so important factor is I is equal to 1.5. The response reduction factor for superstructure is given in table number 3 of IRS is 2, and SA by G is spectral acceleration coefficient is considered as 2.5, and vertical seismic coefficient as per codal 2/3 of the AH. So AH is equal to 0.09375 and AV is equal to 0.0365. I simply input the values in the formula for AH,
हां बोल
and
बोल.
2/3 for this is 0.06250.
अरे बापरे, नको नको जाऊ दे,
Then
तू थांब,
we
नको
have to
जाऊ नको.
consider I have calculate the moment coefficient
गाडी पण नाही
coefficient for dead load and live load. So for that
लगेच
we
चार हजार
required
रुपये
the lever arm for dead load and live load. So lever arm
म्हणून
for
तुला
dead
तेच
load is the
सांगतोय,
CG
तू जाऊन
of the
पंधरा
from the
मध्ये
bottom of the girder, and lever arm from the live
म्हणजे
load is
आपल्या पण
2.6
ज्याच्या
meter is the
तिकडून
CG of
लागली
metro
मध्ये
from the
समोर
socket of the
समोर रे
girder,
आणून धरून
and
जोडून
center to
दाखव
center
बिल
distance
देणार,
between two web.
बिल देणार काय देणार.
This this
अरे पण हा असू दे ना, जाऊ दे ना, आपले दोन चार
this
एक्स्ट्रा.
two web center to center
अरे
distance between two
ऐक
web
ऐका,
is
मी जरा मीटिंग चालू आहे, मी तुला परत फोन
3.82.
करतो, थांब जरा. हां
3.82. So for moment coefficient calculation, The AH factor multiplied by CG will give the moment divided by center to center distance between two web. So 3.82. So moment coefficient factor is 0.0161. It is the why I calculate the moment coefficient factor. We have to convert the self-weight movement into the seismic movement for that. Load coefficient is for per wave is 0.061, and for total U girder is 0.161 into 2. For live load, same concept. The CG of CG will be the change, and the values are as per. Seismic bending moment at midspan. Here, our bending moment due to dead load from the STAD is 5960, and due to SIDL is 33570. And bending moment due to live load at midspan is 50%. We have to consider for transfer direction, and it is 2125. So for transfer seismic bending moment, it is 5960 plus 3370 into 0.0322. That factor, coefficient factor, plus self-weight live load bending moment into live load factor. So here we get the seismic moment bending moment from for the transverse direction. Similarly, we have to work out the vertical bending. So vertical bending, the AH is uh, 0.0625 as calculated earlier. The value of bending moment is 716. So as per this, we have calculate the seismic moment, and then now the wind load. Wind load, the basic wind speed as calculated as per IS 875 part 3. So basic wind speed is as per figure 1 of IS 875 in Bangalore location is 33 meter per second. And as per code and provision, the value of K1, K2, K3, K4 are calculated and also written here from the clause number, several clauses. So Vz is equal to Vb into K1 plus K1 into K2 into K3 into K4. So it will come from this value is 35 meter per second square, and Pz is equal to zero point 0.6 Vz square is equal to 0.735. So our exposed area is our height of the U girder for when the load acting on superstructure only. So our area exposed area is 1.87, and the force will be 0.735 into 1.87. It is 1.37 kilonewton per meter, and the lever arm for that is is simply h by 2. Zero point 0.5 into 1.87 is equal to 0.935. Now, similarly, we have to transfer the that load in vertical direction. So, 1.37 is the intensity into lever arm divided by center to center distance between the wave. So, it is for single wave it is 0.336, and for vertical for total for U girder it is 2 into 336 because we have two wave. So now with live load we have to calculate exposed area uh, above depth of superstructure is 1.312. So the here superstructure height will be not considered. It is 3.12 is above the superstructure. So force is as calculated earlier is 0.735 into 3.12 is the exposed area. So force is 2.29, and lever arm is zero point 0.5 into 3.2 plus 1.87 is depth of superstructure. So total is 3.43. So vertical load per wave is 2.29 into 3.43 divided by the center to center between the bearings in transfer direction. So 2.05. Similarly, vertical load per girder is 2 into that value is 4.110. So total vertical load on U girder is 0.67 for only when only self-feed is there, up to the 1.87 height, and with live load, it is 4.79. Then our girder is simply supported in the longitudinal direction, so the moment is WL square by 8. So here we will get 4.79 is the intensity as UDL into center to center span divided by 8 is 525 kN per meter. So now after application, and as I mentioned that I have considered several nodes in between total 31-meter span. The bending moment for the self weight and superimposed dead load and live load for bending moment and live load for shear force are tabulated. So for the design, for the time constraint, I have considered the uh, s- uh, uh, example of calculation of stresses at the midspan for the 15.5 meter. So here self weight bending moment is uh, 5960. SIDL bending moment is 3370, and live load bending moment is 2249. So now we move to the load combinations. So load combinations are given in IRS CBC table number 12. So for dead load, dead weight it is for ULS 1.25 and for SLS 1. SIDL for ULS is 2 and SLS is 1.2. And for live load is 1.5 in ULS case, and 1.75 is ULS case, and 1.1 is SLS case for live load. So we required majorly the three loads: dead load, superimposed dead load, and live load, because the it will be critical only in the combination. So here moments at midspan I have calculated. So as I shown, the dead load bending moment at midspan is 5960. SIDL bending moment is 3370. Live load bending moment is at midspan is 4249. Then similarly, that self weight wind load bending moment is 525. Seismic transverse and seismic vertical is 716 and 752. Here is the load combination. First one is dead load SIDL and plus live load. So for dead load is serviceably limited condition. There are two condition for the design: serviceably limited for stress check and ULS for ultimate design. So we are looking at serviceably limited. So for serviceably limited, factor dead load is 1, SIDL 1.2, and live load is 1.1. But here we consider the CDA factor also, impact factor. You can say the coefficient of dynamic argument. For that, its value is 1.397 is coming. Uh, so we now second combination wind load is considered, and third combination seismic transfer seismic vertically is considered. So the critical combination is coming dead load, SIDL, and live load. So for further calculation, I have considered only the first one combination. So you have to check which combination is going to critical. So here what happened here, my wind pressure is also less, and seismic zone also 2. But sometimes in seismic zone 3, 4, 5, this case also can be critical. So accordingly you have to go for further calculation. Similarly, for ultimate limited, only the factor are changing. All the moments without factors remain same. So here also the combination one is going to critical. So I have used for further calculation combination one only. Now we will move to the stress check calculation. So stress check SLS condition at midspan I use. The ultimate free stress is 1860 Newton per mm square. At the time of jacking, we have to consider is 0.75 into ultimate free stress. So it is 395 1395. So here is the basic theory of free stressing I have presented. The distribution of free stressing force and bending moment uh, for P by A is all section in compression where the free stressing applies to the structure. Then free stressing moment P into E by Z. It will be give the compression at bottom and top there is some compression and self-weight bending moment is as you all know the as per shape of the bending moment diagram that there is always tension at bottom and compression at top at midspan. So similarly for SIDL same similar pattern of the stress is will be there and live load also similar pattern of the stress will be there. So in summation of all these stresses there will be no any tension at final stresses. So that we have to take care. Accordingly, our number of stand or number of cables, number of tendon we have to increase, or the in some cases we have to change our construction also to uh, provide the compression at any section. So now in pretension, first the stand are stressed. So very first loss will come in the picture is relaxation because concreting has been done after 2 3 days uh, as per the construction practice. So first loss is coming into picture is relaxation. So relaxation loss work out as per the IRC 112. There are table given in IRC 112 6.2 and 6.3. So relaxation loss at 100 hours is 3.5%. So here the table is given 100 hours and our PU by FPU fact is ratio there 0.7 and 0.8. So our 0.75, so we will consider by interpolation is 3.5% of the 3% loss. So uh, at the time of transfer, I have assumed the 3 days, so 72 hours. So relaxation loss up to 72 hours percentage of 100 hours is 66.8 is calculated from table 2 6.3 for low relaxation steel here 20 and 100 hours. So our value lies between both two the interpolation between two values. Then the percentage of loss is 3.5% into 68 by 10. So 2.34% loss uh, in prestige up to 72 hours by only relaxation. So the loss in prestige is calculated by 1394 is the original stress minus 2.34% of its percent. So remaining stress after 72 hours is 1362 in tendon. Okay. Then the final relaxation loss is as per codal provision 3 times of the 1000 hours loss. So 3 into 3.5. So 3 into 3.5 into 39 1395 divided by 100 is 146.475. That loss is total final loss, but we have considered the loss in at 72 hours. So from that final loss, we have to reduce the loss up to the 72 hours. So effective loss is 113.832 effective final loss. Then the loss due to elastic shortening. Elastic shortening loss is the stress at the level of steel. Average stress at the level of steel only. So here FCK is M660, EC is equal to 36 000, ES is equal to 195,000, and modular ratio is ES by EC is 5.42. So stress at the CG of pressurizing force, there is simplified formula P into 1 by A plus E square by I. Normally it's P by A plus M by Z. So from that formula, this formula is derived. So total area of pressurizing stand. So number of stand at midspan into area of one stand. So number of stand at midspan I have considered 92. So 92 into 140 is the area is given in problem statement. So total area is 12880. The prestige after transfer. At the time of transfer, is effective prestige is 1362 because there is loss in relaxation. So the total pressurizing force is area into stress. So effective pressurizing force is at the elastic at the time of transfer is this. Then the area of U girder as calculated above. Moment of inertia also we have furnished from the AutoCAD, and CG of the cable from the socket. So uh, 46 cable are 80 above from the socket, and another 46 number of cables are 80 plus 70 above. So from that the CG of uh, cable we have worked out, and now we have to work out the eccentricity. So eccentricity is nothing but the CG of the girder minus CG of the cable, and ZB and ZT is the moment of inertia divided by the uh, Z distance. It is uh, CG of that top and CG of from bottom. Uh, so the stress at CG level of pre-stressing transfer is calculated from that this formula. It is coming 13.87. So next it so loss due to elastic deformation is moment. Uh, Now the moment at midspan. Moment at midspan is 5960, and here the ULS factor is SLS factor is 1. So directly consider the bending moment bending moment at 5960. Eccentricity similarly, then stress at CG of girder, sorry, is due to self weight is 3.65. So total stress at the transfer of the CG of girder is 13.87 and minus 3.65 is 10.22. So considering average stresses, here is say 10.22 is at midspan, but throughout the span it will be different stresses. So average stresses throughout the span is 8.4. So the pre-stress loss is m into average stress. So m is 5.42 and average stress is 8.04. So 43.55 Newton per mm square is loss due to elastic shortening in the pre-stress. So total force minus area into stress loss. So effective pre-stress is 16,987 remaining after elastic loss. So now next after elastic loss we have to again check the stresses at top and bottom and CG of the cable. So for that P by A plus M by Z and minus mg. Mg is the moment due to self weight and ZT. So from that top and bottom, this is at top and this is at the bottom stress, and average stress at piston transfer is 9.77, and permissible stress is for compression 20 MPa and for transfer tensile stress is 1 MPa. So then after the creep loss, uh, as per clause number 5.2.4.1 of IRS, the creep stress is given is 4.3 into 10 raised to minus 5. So creep loss is simply that creep strain uh, average stress into E, elastic ES. So from that average stress uh, for the creep is 7.71. So 7.71 into 4.3 into 10 raised to minus 5 into ES. So 64.64. Actually, IRS code has simplified and directly provided the value of creep stress in code, but in IRSC 112 they have given various formulas to work out the creep stress. So in IRS it is very simplified creep stress given in the code. So loss due to shrinkage. Shrinkage also they have given the shrinkage strain is 0.003. So loss due to stress is strain into the stress E value. So it will give the stress. So total loss due to relaxation as calculated above is in residual minus total loss minus 72 hours loss. So total loss due to creep shrinkage and relaxation is 237.03. So we have to work out the effective stress after all the losses. So if loss in stress due to shrinkage creep and relaxation is 3053. So effective stress uh, is we have to reduce that force that calculated earlier is 16987. So here similar way we have to calculate the stresses at top and bottom after reduce the forces. So we need to check that all are permissible limit in or not. It that we need to check in all the sections. So here I consider mid span. Now after application of the SIDL, so we have to understand the flow of the construction method. At which time which load is applying. So now SIDL moment which is factor moment as 1.2 factor consider in this moment, and M by ZT and M by ZB top and bottom girder, and previously we are remaining 4.2, so 4.2 plus 5.56. So as we go further loading, there is a increase in compression uh, at top, and it will reduction in compression at bottom. It will be seen. So now after that live load application.
Hi.
After live load application, the we can see the stresses. In similar way, we have to work out the live load uh, as SIDL. So MQ is the minimum moment at live load with the impact factor, and impact factor with the CDA and the partial safety factor. So it is 8.15 at top. In it is a compressive stress, and at bottom is uh, tensile stress minus 4.41. So summation at our residual stress at up to the SIDL is 9.76 at top. So 9.76 plus 8.15 17.9, and at bottom is our residual is earlier 4.55. So 4.55 minus 4.41 is remaining 4.14. So the check this is service condition. The permissible compressive stress in stress at service is 0.4 in point FCK is 24 Newton per mm square, and there is no any tension permissible at service stress. So by both the condition are satisfied to solve our problem at midspan. So here are different sections I have worked out because we have very short time. So each and every section we cannot elaborate in this presentation. So at the top girder and bottom girder, our stresses are there. Now As the midspan bending moment is very high and it is gradually reducing towards the support. So we have to provide the curtailment in the precessing tendon. Curtailment in precessing tendon between means what? Here the debonding of the tendon will required in pretension because there is we have to lose the contact between the concrete and steel for curtailment. So at midspan, total 92 stand are active, and curtailment 1, curtailment 2, and curtailment 3, curtailment 4. I have furnished tabular below. That number wise, I have given the numbers for each stand. 1, 2, 3, 4, 5, 6, like that, up to the 92. So for debonding stress and curtailment, we have to give uh, in our drawings and mention very clearly because the debonding of the stand has to be done at site. So site have to understand which rebar has been demanded at which location. So at midspan, total active bond is 92 and 6.4 meter distance from the support is 68 number of stand are active and 24 are unbonded. From the 4 meter distance from the support is 46 meter activate and 46 meter are demanded, and 2.5 meter distance is 30 are active and 64 are demanded, and 1.4 meter from the support 16 are active and 76 are demanded. Why we have to demanded that stand? Because the we cannot uh, provide full active full stand at throughout the section, because at support there is no any bending moment, but due to precious movement there is a huge movement developed, and the girders will be hogged and it will be cracked and all damage is there. So very carefully we have to mention. Now the let us move towards the ultimate moment capacity of the section as per IRS 16.4.3 was our of CBC. Here the input parameter and our bending moment as calculated above is 23,646 for ultimate moment capacity. We need to calculate the XU by equal to compression tension. Our XU is I have calculated 1.52 by equating the tension force is equal to compression force. Uh, and here is the CG at 242 26 628 is the total length of the wave, because uniform section will pass after the 628, and the top flange is 700 at right side and 500 is left side, and the strain is 0.035 at the top and 0.015 at that distance. As per this parabolic curve, 2.44 into 10 raised to minus 4 divided by square root of fck by ym is 0.015. So for in compression force, we have to simply calculate the area from the AutoCAD and CG from the AutoCAD, and stress as 26.8. So total force at top bulb is 7.7 triple 72 is CG into uh, stress area into stress, sorry, area into stress, and bending moment is CG into that force. Bulb will give the more compression force than the wave. So here the compression force is 19659. So for steel also we have to, I have equated that 19.659, uh, that 46 two times precision stance and area of precision of 140 AST is 1664. CG from the bottom and 80 and another cable is 180. So from that equating tension compression to work out, and also take advantage as I mentioned earlier. Also I have taken the advantage of rebar. Is 79 is 79 means that area of 10 and 201 is area of 16 square. So HYSD uh, contribution of HYSD also I have taken to work out, check the capacity. So from that lever arm we have to work out. So from lever arm 1.87 minus 0.39 minus 0.115 is the CE. So for the force into lever arm, our capacity, moment capacity of the section, and actual bending moment is 23.6, 23.646, and here the capacity of the section is 26,834. So we are in shape in this ULS also. Now we moved to share near the support. As I mentioned, we have to consider relative moment with respect to share. So this moment is there, bending moment and shear force. The maximum factor shear force due to shear self weight is 1015. Due to SIDL is 914, and live load is
सुगे ने
1460.
कंफर्म कर दिया
So total factor summation of this is 59
अभी एक
uh,
तारीख मतलब 8 तारीख को पोस्ट कर देंगे वापस
3391.
शायद प्लान के लिए
Now ultimate shear
प्लान
capacity of the section we have to work out.
ओनली
So FEU is equal to 1860, FCK is 60, ES and partial safety
अभी
factor.
पाँच में
The
हमारे वहाँ पे
pre-stressing force at
पेंडिंग है
support
तो सुगे वाला
at
कर रहा है
transfer
सब
is
कंफर्म नहीं होता
2937. At supports we have demolded the area, demolded the cable,
मैटर भी थोड़ा
and
सा
only
पीछे
16
से उसको
cable
करना
are
पड़ता 90 छोड़ना रहता है
active.
ना दीवार
So
से पेड़
hence
लेके
the force is
तो
very
बहुत कम
less
छोड़ा है और एक
um,
जो झोपड़ी है अभी भी वो
in
डिस्प्यूट में है अभी
pre-stressing
भी
force. So, and loss in pre-stressing force
वो
is
अभी उधर ही रहता है कोने पे
minus
सब
0.321 is considering elastic shortening, creep, shrinkage, and relaxation. So effective pre-stress is 2416,
पार्किंग
and
का इशू है पहले फ्लोर में पार्किंग ही नहीं दिया जाता
stress at
मतलब आगे
CGI
का
due
20
to
बाय का
compressive
टावर है
stress
पीछे का
FC
कुछ
P by
ऐसा
A.
18 17 ऐसा 3
So here P is equal to uh,
10 है
a
नीचे शायद वो
2416,
पार्किंग नहीं दिया
and
है
area is
पार्किंग दिया है वो
the
खराब हो गया
our
जो
concrete
स्टैक पार्किंग है
area of U
हाँ
girder. So
वो
1.11.
गया वो
Then the ultimate shear check. Uh, the maximum principal tensile stress is 0.24 square root of FCK 1.86. That I have explained in theory. So wave thickness is there are two waves of 230 so 460, and overall depth of the member is 1.87, so 1870 mm. So VCO is the 0.67 into B into H into square root of the FCP uh, plus FCP is here the if part portion of effective pre-stress will be coming. Then the total capacity is 1320 from this formula, and our ultimate share at this location is 3390 is support. So CG bottom of hence the share reinforcement is required. Then CG from the bottom of stand is 115 mm. Then CG the distance of CG from the tension zone is 1870 minus 115 7 1755. So wave thickness is 460. So maximum shear stress is 3391 into we have to convert the in the Newton. Divide matlab U by BD, the formula 4.2, and permissible stresses for M60 grade as per code is 5.8. So the shear reinforcement is net shear is total ultimate shear minus ultimate shear capacity. So remaining shear is 2071, and web thickness 460. Effective depth is 1870 minus 50 cover minus dia I have assumed. So is 1790. So as per this formula, we have to work out the area of steel. ASV by SV is equal to V plus V. V is the total actual force, and zero point 0.4 B into dt. Zero point 0.4 B is the width, and dt is the depth, and VC is the shear capacity. Is you have to unit minus. So we can use the net
क्या
also,
रात में
or
दोस्त ने
otherwise
बारिश अच्छा
actual
वाला जो भाई वो फटाका
ultimate
पूरा फुल हो
shear
गया
plus zero point
इसका
0.4
शिवाजी पार्क का
into
और उसके बाद
wave
15 मिनट के बाद
thickness
बारिश आ गई जैसे
into
बाहर
wave
आ गए
depth
हम लोग
minus that shear
बहुत
capacity
बहुत बहुत
of the
बहुत
section.
बहुत
So it is 3.714 mm square per mm. So suppose we have to provide the in 150 mm,
सब
100
ऊपर
mm
वाले
center to center. So we have to multiply it by that.
लक्ष्मी बॉम्ब
So this much area and reinforcement. So now we come to the transverse analysis of the U girder. Our session is going to uh, very long actually. So now we have to increase the speed. So similarly, for the same problem statement,
हाँ
the basic data of the
हाँ
superstructure
सब
span
सब
center to center
तो
31
अपने
meter,
घर में छोटा
bearing
जितना है
center to
उतना
center is 26.9 meter. Grade of concrete is M60. Grade of steel is 500, and clear cover to the reinforcement is 35. It is for RCC. As I mentioned earlier, the transfer analysis only the RCC section will be to consider. So sulfate
अच्छा
density is 25 kilonewton per meter cube, and superimposed end load as a furnish about table. The rail and plinth sulfate of plinth is 1.72
हाँ सर
ton. So there are
नहीं ये मीटिंग जाइए ऐसा क्या
0.86
नहीं
ton
शनिवार
per
को
meter.
होगा
Sulfate of
मीटिंग
rail
चालू है ना शनिवार
is
से आपका चौथा शनिवार तो चालू है
0.15
मम्मी
for
पर
two
मैसेज
rail.
टाके
So
परवा ज्वाइन
single
होगा
rail we have to consider 0.65. The total load is 0.935 ton meter is converted to kilonewton per meter. Now the cell weight of lightweight deck drainage. So it is 0.12 divided by 3.82 is the center to center span between the girder. Center wave is 0.31. So weight of cable through, cable stay. As I earlier stated in longitudinal analysis, same values I consider and apply. So UDL we have to work out. Total summation is 8.47. So 8.47 divided by 2. So here we have model two wave. So each wave we have to provide the load of 4.2183. Also solar panel individual wave is 0.49. OHE mast weight is zero point 0.2 ton per meter. So live load in the for transport analysis we have to run the live load as a line model, not as per EUDL. So here the train spacing we have provided A is equal to 2.02, B is equal to distance between two spacing 2.5, C is 12.7, and total length is 2A plus 2B plus C is 21.74 meter of the one bogie, and dispersion width is 1s to 1 consider. So here the 3D model I have prepared for transfer analysis, and the thicknesses I have provided as actual uh, wave thickness and all by giving the properties and by giving the plate sizes and properties, average plate size and average properties where the section is changes. So here the bending trace diagram in x direction due to self weight, uh, y direction, y, xy direction, and is shear stress. And as longitudinally, we have to also convert divide the U girder in three zones. So first zone is from 1 meter from the CJ. Here, uh, here due to that changes in the behavior of the structure from different interval, we have to calculate the uh, we have to check the section at once near the support and in between support and midspan and at midspan. So I have checked our structure near the support for zone A. So plate number 861 is there, which gives the maximum bending moment. So plate number 861, the result are for plate number 861 is are tabulated. The bending mxy total summation into partial safety factor. So here we have to take a ultimate moment. So for live load is giving hogging moment, maximum hogging moment at that plate. There is no sagging moment due to live load at support. So the summation of total is 58.19 moment, 9 kilonewton per kilonewton meter. And as I mentioned, that is a bottom section and transfer analysis will be done per meter width. So B width of beam is 1 meter and depth of beam is 400. So
हा
that
लेक्चर
is
चालू आहे
nothing but
सर
the
कंटिन्यू
depth of
झालं
that
तर
bottom
टाकतो
slab.
सर
The effective depth is
ते
400
झालं
minus
का मी परत
35
मेसेज टाकतो
is the
की
clear
ब्रिज
cover,
जॉईन
and
म्हणून होईल
I
असं
have assumed that 10 mm die
झालं
will be
ना
sufficient.
होईल
So
त्यांचं 5-10 मिनिटात संपणार
as per that we have considered the
मी
effective depth
सरांना
is
असा मेसेज
360
केलाय
mm.
ह्यांना अभ्यंकर
So
सरांना
depth required
मग
is
त्यांचा एक
equal
5-10 मिनिटाचा फक्त
to, as
स्पेशल
per
लेक्चर
ULS
होईल
formula,
असं
that m is equal to 0.15 into FCK BD
त्यांनी हा
square. So here square root of FCK,
ते काय
square
होतं
root of
ऍक्च्युली
m
नाही
divided by
रेकॉर्डिंग
0.15
चालू आहे
FCK
तिकडे
B. So depth
हा
required
म्हणून
is
ते
80 mm
मध्येच
for
जाईल
that particular moment. So we are safe.
हो
And the lever arm
ठीक
factor Z
आहे
is
मी
equal
झालं
to
का लगेच
minimum
मेसेज
of
टाकतो मी तिथून कॉपी
1
पेस्ट
minus
करून ना मीटिंगचा मेसेज लगेच
1.1
टाकतो
Fy into AST divided by
हो
FCK
हो
B into
व्हॉट्सअप
D.
वर टाकतो
This formula is given in IRS CBC. It should be limited to 0.95 of the D. So AST provided is 10 dia plus 10 plus 10 dia at 100 center to center, so 1.75. So I have checked the reverse calculation. So Z is equal to, as per AST provided, is 0.96. So therefore we are consider 0.95. So AST required is equal to M divided by 0.87 Fy into Z. So M is equal to 58.19 into divided by 0.87 Fy into 0.95 into D 360. So 391. So we have provided 1571. So it is
गुड़गांव में
okay.
बारिश गिरा था जोर
So
से गुड़गांव में भी
serviceable limit state, we have to check.
सब
We
सब
have to
वाला
also
एकदम
check the section for
सब
the
हो गए
serviceable limit state. So in
अरे
this
कल ही हो गए
uh, same plate I have considered for that. It is going to critical bending moment. So here also I have tabulate uh, factor moments with the
12:30 बजे मीटिंग है
SLS
मुझे
factor.
ISSE
So total effective bending moment is
हाँ
29
ऑनलाइन है
kilonewton. So permissible stress is in concrete for SLS zero
ये
point
लेक्चर
0.5
चालू
into
है ना
FCK is 13 Newton per mm square.
ऑनलाइन
Permissible stress in steel
ये
is
ऑनलाइन स्टूडेंट के
375,
लिए
nothing
लेक्चर
but
है
0.75 into Fy.
इसके बाद वो ISSE
And the
का
model
मीटिंग
ratio
है
is 280 by FCK is 280 by 60, 4.667. Control axis factor N is equal to that permissible stress in concrete divided by uh, that permissible stress is divided by M, model ratio plus 30 is equal to 0.272. So lever arm is equal to 1 minus N by 3 is basically the SLS uh, case. So 1 minus 0.272 divided by 3 is equal to 0.909. So moment of resistance Q is equal to 0.5 into N into Z into 30. 30 is permissible stress in concrete. So 3.708. Similarly, here also we have to consider same width per meter, depth of beam is 400, effective depth is 360, and effective depth required M by QB is equal to square root of uh, 29 10 raised to 6 conversion factor divided by 3.078 708 into that B 1000. So 88.4. So area of steel required is M divided by sigma st ZD. So area M is equal to 29 into 10 raised to 6 divided by 375 is the concrete permissible stress in steel into that Z value into D. So 236 mm square. So we have provided area 1571 mm square
एक
Sehn
तारीख
square.
को
Now we have to check the crack width also for that in transfer direction transfer analysis, because we have assumed that RCC section in the transfer analysis. So crack width as is formula given in IRS CBC for the crack width is 3.3 into ACR uh, into strain divided by 1 plus 2 into ACR minus C nominal clear cover divided by H minus DC. So the strain in steel is FCM, average strain in steel at level is summation sigma 1 minus 3.8 BT H bracket में A dash minus DC divided by strain of steel into area of steel in bracket H minus DC, and 1 minus MQ by MG in 10 raised to minus 9. This is the ratio. MQ and MG is the ratio of live load and dead load bending moment.
Jayant, one small disruption. I
Hmm.
think you'll have to go a little fast. Maybe you can skip
Yes.
this and go to the construction issues.
Okay, okay. So there is only one page is remaining.
Okay, okay, yeah.
Uh, that limiting strain in steel is 0.87 Fy by ES is 0.0022. That is a basic formula for the limiting steel, and as a width of beam is 1000 mm, mg is 61.9. 61.9 is from this addition of 2, and 19 by this 19.2. So total effective is 29. ACR is equal to 42 as I calculated here. Nominal C is the effect depth clear cover. Total H is total height, BT and DC we need to calculate. So DC depth of total axis is A into n square plus B into n plus C is equal to 0. The quadratic equation has been formed. So A is equal to B by 2 and P is equal to M into ST and C is equal to minus M into AST by D. From that quadratic equation, we have to work out the depth of total axis as a 56.7. Then the CG of the compressive force is one third depth of the neutral axis. One third into 65.7 is equal to 21.9. So lever arm we have to work out that D minus D dash. So 138.1. So stress at the CG M divided by moment divided by AST into D. So AST this is not even AST provided. Actual stress we have to work out. So M divided by ST provided into that if a lever arm. So 54.6 Newton per mm square, and strain at the level ES is equal to that stress divided by EC ES. So 0.0003 is limiting is 0.022, so is less than limiting. So stress in concrete at top is nothing but D by DC. It is the triangular formula, triangulation formula in strain. So it is 2.6 at top. You have to multiply by m, divide by m here. Stress in strain stress in steel. We have to calculate first at the top, then we have to divide by m. So it will come for concrete. Similarly, uh, E- E1 strains at the outer surface of concrete. Same formula, uh, triangular portion. So and then the ECM is equal to ECM is I have information over here. So ECM is coming to negative. So it means there is a no section is uncranked. So there is no check for the crack width. So that I have uh, provide the calculation of zone A of base slab. Likewise, we have to work out the side wall also. Similar pattern we have to work out side wall also, and of another two zones. Even where we need to check which plate giving the maximum bending moment, and that plate we have to consider and provide the calculation for the similar kind of the thing, and repeat again. So it is repetitive work. Once you work out one point, so then rest is a repetitive work for that. So for a zone A, zone B, zone C, there are base slab uh, 10 at 100 center to center, side wall 16 at 100 center. Uh, 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 Similarly, in zone B, 12 dia 150 center to center plus 12 dia 150 center at top and bottom of the base slab, and 16 dia 150 center to center and 10 dia 150 center in inner side and outer side of the wall. And similarly, at mid portion, 16 dia 200 center to center plus 10 dia 200 center to center at bottom. Here we see the at midspan, the spacing will increase the area uh, of reinforcement will reduce. Uh, this I have done the validation with manual calculation. So all parameters I have considered, and the bending moment as actual and theoretical we have to compare. And the comparison in the terms of material with the eye girder I have done. So the volume of uh, girder is for U girder is 136, where same suppose we provide two girder of 31 meter span eye girder with the deck slab and that parapet wall, so it will comes around 206 meter cube concrete volume. So there is saving in 70 m cube in concrete, and also the area of reinforcement is in deck slab it will be increase in eye girder, but in U girder is monothically U type shape, so there is 175 kg per m cube the area of reinforcement, and the required steel is 24 ton, and here 26.8 ton, so total 4.6 ton saving in if you use U girder instead of I girder, and amount of pre-stressing also 3.76 ton is required to for U girder, and 7.6 is required for I girder. So here are some benefit. U girder is effective base fit. No need to extra component of U. Parapet is not required for OHE mast and walkway. Reduction in size foundation. Reduction in other component due to fear in height, like the approaches and all. Saving in quantity is around 20%. So now we move to construction aspect. So here the basic reinforcement gauge for U girder has been placed. Reinforcement gauge. The lifting of reinforcement gauge by tower crane. Here the placing. of concrete uh, for shuttering. They have placed
एक्चुअली उसने हमारे
formwork
अंदर पहले क्या किया था, इसमें भी 2 फीट है
handling
और थोड़ा सा एक
after
पार्ट उसमें भी डाला था, जो हमारा था ना
uh,
पहला वाला, एक फ्लोर
casting
पे
yard. We have to place,
410।
remove that, and the new gauge will be shipped or to faster
हम
the
तो रेडी हो
construction.
गए, हम तो 405 बेसिक पे थे।
It is the transportation to the site and installation, girder erection
हाँ
of the
वो
cranes, and here is the complete
चार सौ
viaduct
पाँच हम लोग बेसिक ही
map.
पकड़ा है ना, वो तो समझ जाए थे।
By this, I have concluded my
वो भी नहीं, अभी शाम पे समझेगा।
presentation.
हाँ रेरा मुफा तो अभी नहीं है।
Sir, I hand it over to you, sir.
Okay, excellent presentation, Jaywant. I had been, pointing out to you regarding time because, of course, time is also an essential component, and I think participants were enjoying your calculations, transverse analysis, crack fit calculation, etc.
Hmm.
What we will do is we will share your presentation PDF to participants
Hmm.
so that they can go step by step to your calculations. So now
Yeah,
let
yeah,
us,
yeah.
without any further delay, we can go to the question answers. So
दादा
there
को तो सब
are
फ्लैट्स
there
मतलब
are
सेल हो
two
जाते हैं।
questions. One is a question which is saying, what is a thrust line in a pre-stressed concrete? In simple language, why thrust line is important in design? How can thrust line make optimal design?
Okay, okay. So thrust line is basically used in a post tensioning
ये
actually.
वडरा का सर के पास।
Uh,
हाँ
Yeah,
that
because in your
uh,
case you use pre-tension,
uh,
but still you have
uh,
done a debonding.
still
Yeah,
we have to done with debonding. Thrust line in the it means you have to do the profile to in such a way that your bending moment profile
वो भी
will
एंगल
be
बहुत
replica
अच्छा
of that
उसके बाल वो भी सब
cables. So in that way, we have to play with the eccentricity basically of the
हम लोग
pre-stressing
मतलब वो कैसा एक साथ प्लॉट चाहिए, एक साथ प्लॉट
force.
नहीं चाहिए था।
yeah. Probably he meant to ask about those Kern points and Magnell
Yes,
diagram. So that
yes, yes,
I
yes.
think you indirectly explained during your longitudinal analysis the top
नहीं नहीं,
stress,
मैच
bottom
मिला के
stress of
करना चाहिए था,
zero,
उन्होंने क्या किया, सिंगल
then
सिंगल
top stress, bottom
कहना चाहिए
stress
था।
in the transverse stage.
Yes, yes, yes.
बहुत ट्रैफिक रहता
I
है।
think, yeah, there is second, there is not a
कितना पड़ेगा
question, there is a suggestion. ICC President Vadalkar sir had asked uh, if you can provide PDF of step-by-step calculation for U-shape girder. It can be
Mm-hmm.
kept on our website for reference. So, Jayant, you can share your calculation.
I will share within a week actually, week of time.
Yeah,
Or
take your time, but at least
yeah,
share in week's time.
yeah, yes, yes.
Then there is a question by Abhijit Gavai. He's asking, it was very detailed and informative session. I have a few questions. How much, question number one is how much should be typical span of U-trough girder for metro system and would it be economical?
Actually, it is by various study, and it is around 30 to 31 meter is the economical. So beyond that, it is design and all because the bending moment at midspan will be increased. You can see that after 30 meter span center to center, where residual stress is around 0.14 at midspan, and we cannot also increase the number of tendon. So I think 31 meter 31 meter is the maximum economic span. Then after we have to increase the tendon, and it will be the increase in the depth actually, base lab depth and all.
Yeah, and in some places like in Mumbai and Delhi, what they have done is they have kept the 35-meter span and they have increased the span of the pier. Okay,
Ha
so
ha ha.
it
Yes, 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 yes.
looks like
By
the
that way,
span is, yeah, the width of the
flare,
pier is
flare,
increased.
flare, pier cap they have provided
Yeah.
also.
There is
The
a
width of
second
pier cap.
question by Mr. Abhijit is, what is a governing criteria for selection of U-trough type?
Uh,
So I
as
think
per
you have
the,
covered that eye girder and box girder
ha
and U-trough.
I have made a comparison for that. uh, Governing criteria, but in it is very cost effective in terms of metros, which compared to other type of superstructure. So if any obligatory structure is there, so there is no an option to provide that on another structure. But UTUFs have its own limitation actually. The
किधर किधर पहुंचा
curvature
वो देखो.
factor of that metro, because in
नहीं वो
metro
तो
city the
11:30
restriction
बजे
of
ओवर
land
ब्रिज
and
के पास
all,
था. निकल गया था
so
शायद.
we cannot provide UTUF with a large curve. So it is up to
हाँ.
uh, 700-meter curve is
अरे वो तो 1:30 बजे तक खत्म हो जाएगा, तो
I
1 बजे
think
तुम लोग फोन कर दो ना,
700-meter
मैं फोन
curve
नंबर
is
देता हूँ.
sufficient, but less than 700-meter curve we cannot provide U
इधर
girder.
से मांगा था ना, पांडे आने वाला है क्या?
Hmm.
Because that clearance is very less, side clearance, so
तो
it
फिर
will
एक
be
काम करो ना, फिर
due
अंडर
to
आइस
that
मंगा लो ना.
centrifugal action, that uh, bogie will be hit the side wall, so
Okay.
that
And wherever
हाँ
your
वही वही.
metro lines are
एक
changing from
वो
one
लाओ, एक
track,
अंडर आइस लाओ,
the
है कि नहीं?
metro is entering in the other track. There also you can't provide U-trough, right?
there
You have
also
to
we
go
cannot
for
provide.
किधर अपना
Huh,
पॉपुलर?
high
UTF
girders.
has its own
किधर से?
limitation actually. We cannot
हाँ
provide
हाँ हाँ.
over there.
अरे इसमें
There we
अंडर
have
आइस
to
में भी आ जाएगा ना.
go for
Crossing.
another
हाँ
option.
ठीक है, चलेगा ना.
That
चलेगा.
eye girder is very much suitable for that type particular crossing.
Yeah, we'll take a quickly last question by Mr. Gawai. He is asking how transportation and lifting stresses were considered.
Lifting portion I will not cover in this, but lift for lifting that the moment due to lifting hook we have to calculate for at the position.
Probably when you share your Excel file, a design PDF, there you can add that lifting calculation.
Okay, 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 sir.
Yeah, guys, I think we have almost shoot up the time which we regularly take. So